Hey Aiden. So yeah, this is definitely one of the harder questions because it requires you to not only be able to read the pedigree, but then to know enough to do the Punnett square that you need to do to figure out the actual answer to the question. So I thought this might be a little easier because my explanation got really long when I was typing it out. So the very first thing we have to do is figure out what is going on in this pedigree. You have to figure out, is it autosomal or X-linked? And then is it dominant or recessive? Autosomal just means it's linked to chromosomes 1 through 22. It's going to be your typical big A, little a, or some other copy or some other mix of those. If it's X-linked, it just means it's linked to the X chromosome. So you're going to have one of those two options, an X with a capital A or an X with a lowercase a. And males are XY and females are XX. So there's a little bit of a different dynamic there. Males can be X capital AY or X lowercase ay. They can't be carriers. They only have the disease or they don't. Females can be carriers if they have one capital letter and one lowercase letter. Now, this trait happens to be X-linked, not autosomal. And I know this because of one main thing. All of the affected people are males. When it's X-linked, you will find that more males than females are affected, usually by a lot, a big factor. If it was autosomal, you would see about an even mix of males and females affected. So now, is this dominant or recessive? Well, we know it's recessive because every single person who has the trait has two parents that do not have the trait. If it was dominant, every parent would also have to have the trait. One of them would have to have that capital A to pass on. If they have the capital A and it was a dominant trait, then they would have the trait too. So this one has to be linked to the lowercase a. That way you need both of them in order to see the disorder. Or if you're a male, you only need one of them. So now let's go on to the second part, because now we figured out that this is X-linked and it's recessive. So now we can actually get to the question itself. So the question is saying, if one of these males in the third generation had a child with a female who is a carrier, what is the probability that their first son will be affected with the disorder? So we have to know a little bit of their genotypes here. The males that are affected are going to be X little a y. The mother is a carrier, so her genotype is going to be X capital A, X little a. Now we have to do a Punnett square for both of these to figure out what is the probability that their children will have the disorder, and then we will look at what's the probability that their sons have the disorder. So we set up our Punnett square and we complete it. I'm just trying to get through this quickly for you so you don't have a really long video to watch. Okay, so now we have two children overall that are going to have the disorder. This daughter and this son. These other ones are protected. So these ones are happy. They're not going to have the disorder. But the question was, what's the probability that their first son has the disorder? Well, there's only two possible sons that they could have. They can have the one that does not have the disorder or the one that does have the disorder. So of those two, there's a 50% chance that the son that they have turns out to be a carrier of the disease or has the disease, excuse me. So the answer is going to be 50%. I believe that was B for this one. All right, if you have any other questions about this one or about others, let me know, and I am more than happy to do up another little video like this or something to help explain it to you. All right, hope you have a good night.